This video is for Chapter 11, Section 6. It's all about the surface area and volume of spheres. We've been looking at prisms, pyramids, cones, cylinders, and our final three-dimensional shape is a sphere. A sphere is not a polyhedron because it doesn't have any surfaces. It has one giant surface that just smoothly rotates around. We can't really unfold it. We can't lay it down flat to look at what it looks like. So the definition of a sphere comes out to be the same as a circle. You take a point in space and imagine if we could nail or just anchor to that space and pull a string out 2 feet. And then move that string around everywhere in space that is 2 feet away from that point. Now this won't just make a circle, this will now make a sphere because we will go in every direction three-dimensionally. So it's the set of all points in space that is equidistant from a point called the center. That distance is the radius. No matter where you go on the sphere, it has the exact same distance away from the center. That radius value is going to become really important because it's the only thing we can measure. Next. So, we're going to look at the two different formulas now. Surface area, 4 pi r squared. R is the only thing we need to know. And let's think about this. Pi r squared is the area of a circle, and 4 times, well, what circle are we talking about? This is a sphere. If we were to chop a sphere in half, we get this dome-looking shape here. But if we can divide it perfectly in half, this represents the largest possible circle that we can have from slicing that sphere. If you slice near the top, you'll get a circle, but it'll be kind of small. If you slice right in the middle, that would be the largest flat circle, two-dimensional, that you can find. That is called the Great Circle. It turns out mathematicians have studied and have been able to prove that if you can find the area of that great circle, the surface area of the entire sphere is exactly 4 pi r squared. Not the dome, the whole sphere. The outside of the circle happens to be 4 times the area of that flat surface. Now, from there, a crazy formula is developed by using pyramids inside of a sphere. I'll show this in class because it's very hard to put on a PowerPoint. We're going to use some drawings and other visuals. But we can use pyramids, in which pyramids, if you remember, are 1/3 area of base times height. Well, it turns out the height is going to be the radius. And if we take this as being 4/3, or 4 pi r squared as our base, the surface of the sphere, we end up with 4/3 pi r cubed. Cubed helps us remember that this is volume. Now, when I look at these two equations, or formulas, the only thing I need is the radius, because that's the only thing that can be measured. So let's take a look at how these work. Find the exact surface area and volume of a sphere with radius 7. Oh, that should just jump out as being easy. They tell us what the radius is, so let's just plug in the formulas. Surface area is 4 pi r squared. 4 times pi times 7 squared. 7 squared is 49 times 4, 196 pi feet squared. Done. Volume. Now, volume is not so nice, and I specifically use these numbers because students hate it when neither of the numbers or none of the numbers involved are divisible by 3. So I have 4/3 pi times 7 cubed. When I cube 7, I get 343, which actually cannot be divided evenly by 3. Neither can 4. So I'll multiply 4 times 343 and get 1,372 pi over 3. Now, if I want a decimal answer, I'll go to the calculator. But if I want an exact answer, you need to practice leaving yours in fraction form. I prefer improper fraction form. 1,372 pi all over 3. Just ignore that 3. It won't divide in evenly. Now, another type of problem is, what if I know the surface area of a sphere is 144 pi and I need to find volume? Well, just like on all the previous stuff, The only thing we need is the radius, and they didn't tell us it. But they did tell me that the surface area is 144 pi. And I know the formula for surface area, 4 pi r squared. Both of these have pi in them, so I'm going to divide by pi, and I'm going to divide by 4. So if I divide both sides by 4 pi divided by 4 pi is 1. 144 divided by 4 is 36, and pi divided by pi reduces out. I'm now down to 36 equals r squared. Take the square root of 36, and we've got the radius is equal to 6. That's it. We found the one thing we needed. Volume equals 4/3 pi r cubed. 6 is my r. 6 cubed is 216. Luckily, this time, 216 can be reduced by 3 into being 72. 4 times 72 becomes 288 pi meters cubed. Find the r, plug into the formula. Relatively simple. The last example on this slide actually represents a jump start into the next lesson, which is when we start putting together all of these different figures that we've been studying. We're going to call this a composite figure. I want to find the volume of that shape right there. It's an ice cream cone, except that it's turned sideways, so the ice cream is going to fall on the ground, which happens all the time with little kids. So what we're going to do here is I'm going to say, okay, don't worry about the sphere that's inside the cone. Let's find the volume of the cone. And then, well, there's just half a sphere on top. So we need a good plan. Let's make sure we understand. Half the volume of a sphere plus the volume of a cylinder. Well, the volume of a sphere is 1/2 4/3 pi r cubed. The radius is 3. I'm going to reduce the 2 and the 4 to become a 2. 3 cubed is 27. 27 divided by 3 is 9. And I still got that 2 up there. So 9 times 18 pi. Now, hopefully you followed along there. But if not, you can show your work dealing with your fractions, and you should get to 18 pi. And the other part, we have 1/3 pi r squared times height. That's the volume of the cylinder. R squared is 9. 1/3 of 9 is 3. 3 times 8 is 24. So I have a sphere that reduced to 18 pi and a cylinder which was 24 pi. Add those two together, 18 pi and 24 pi, and I have an exact answer of 42 pi centimeters cubed. Remember that if we work with exact answers, life is a little bit easier. And in the end, we can go to our calculator to find out what 42 pi is. That's it for Chapter 11, Section 6, about the volume of spheres and the surface area of spheres.